In this episode, we look at business architecture trade-offs, which are the choices that connect security design to business reality. Security architecture is not only about building the strongest technical environment you can imagine. It also has to fit the organization's legal obligations, budget, risk tolerance, data sensitivity, growth plans, ownership model, and physical operating needs. A technically elegant design can still fail if it stores data in the wrong country, costs more than the organization can sustain, ignores classification rules, or leaves ownership unclear. You may hear people talk as if security should always choose the most lockdown option. In real environments, the better question is whether the design protects the right things in the right way for the business it supports. That means understanding constraints instead of pretending they are obstacles. Constraints are part of the architecture, and good security design works with them honestly. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. Data sovereignty is the idea that data may be subject to the laws, rules, and expectations of the place where it is collected, stored, processed, or accessed. This matters because organizations do not operate in a legal vacuum. A customer record, health record, payment record, government document, or employee file may have different handling requirements depending on country, region, contract, or industry. When an organization uses cloud services, backups, managed platforms, or third-party processors, it must know where the data lives and where it can move. A system may work perfectly from a technical point of view while still creating risk if regulated data is stored in an unauthorized location. Data sovereignty affects architecture choices such as cloud region selection, provider contracts, replication, support access, disaster recovery, and logging. You cannot protect data properly if you do not know where it is and which rules apply to it. Data sovereignty also affects who can access data and under what authority. A cloud provider may operate globally, but that does not mean every support team, region, or service path should be able to touch every data set. An organization may need to limit administrative access to specific locations, restrict cross-border transfers, or ensure that encryption keys are managed in a certain way. Even metadata can matter because logs, account information, location details, or transaction records may reveal sensitive activity. A business may choose one architecture over another because it gives stronger control over data residency and access paths. This may increase cost or reduce flexibility, but the trade-off may be necessary. When you hear data sovereignty, do not only think about a map. Think about control, law, contracts, operational access, backup locations, and the organization's ability to prove where data has been handled. Data classification is the practice of labeling information based on its sensitivity, value, and handling requirements. Classification gives the organization a way to decide which data needs ordinary care and which data needs stronger protection. Common labels may include public, internal, sensitive, confidential, restricted, critical, secret, or top secret, depending on the organization and environment. The exact words matter less than the discipline behind them. A public marketing brochure does not need the same controls as payroll data, legal strategy, source code, trade secrets, or national security information. Classification should influence storage, access control, encryption, sharing, retention, monitoring, and disposal. Without classification, teams may protect everything the same way, which usually means some data is overprotected and some data is underprotected. A good architecture makes classification practical, so people can understand what they are handling and systems can enforce the right controls. Classification also helps avoid expensive or confusing design choices. If every piece of data is treated as the highest sensitivity level, the organization may create unnecessary friction, cost, and operational burden. If nothing is classified carefully, sensitive data may spread into places where it does not belong. The business trade-off is finding a classification model that is simple enough to use but strong enough to guide real decisions. You want labels that people can understand, systems can apply, and auditors can review. Data classification should not exist only in a policy document. It should show up in architecture through approved storage locations, access groups, encryption requirements, data loss prevention rules, backup handling, and retention schedules. When classification and architecture work together, the label is not just a word. It becomes a practical instruction for how the information should be protected throughout its life. Cost is one of the most common business constraints in security architecture. Security professionals may prefer more redundancy, more monitoring, more automation, more staff, more testing, and more specialized tools, but every organization has limits. Cost includes more than the purchase price of a product. It includes licensing, cloud consumption, implementation, training, staffing, maintenance, support, integration, audits, upgrades, and eventual replacement. A control that looks affordable at first may become expensive if it requires specialized skills the organization does not have. A cloud design that looks inexpensive during a small pilot may become costly when storage, data transfer, logging, and high availability are fully enabled. Cost should not be used as an excuse to ignore security. It should be used as a planning factor. A sustainable control that is operated well may reduce more risk than an expensive control nobody can maintain. Cost trade-offs often involve capital expenditure, CAPEX, and operating expenditure, OPEX. CAPEX usually refers to large upfront spending, such as buying hardware, building facilities, or purchasing long-term equipment. OPEX usually refers to ongoing operational spending, such as subscriptions, cloud usage, support contracts, staffing, and managed services. On-premises architecture may require more CAPEX for equipment and facilities, while cloud architecture often shifts more spending into OPEX. Neither model is automatically better. The right choice depends on cash flow, growth expectations, control requirements, compliance needs, and how predictable the workload is. Security design has to account for both types of spending. A solution may be technically strong but financially unrealistic if the organization cannot keep paying for the people, monitoring, storage, testing, and support that make it effective. Ownership is another business architecture trade-off because systems and data need clear accountability. Ownership answers questions such as who approves access, who pays for the service, who decides acceptable risk, who handles incidents, who maintains documentation, and who can retire the system. Technical teams may operate a platform, but the business may own the data and the process it supports. A vendor may host an application, but the organization still owns the responsibility to protect customer information and meet contractual obligations. Confusion about ownership creates security gaps. A server may remain unpatched because the infrastructure team thinks the application team owns it. A database may keep old data because nobody knows who can approve deletion. A cloud account may grow without review because every team assumes someone else is watching. Clear ownership turns architecture from a collection of resources into an environment people are accountable for protecting. Data ownership deserves special care because data can outlive the systems that created it. A business unit may collect customer records for one purpose, an analytics team may reuse them for reporting, a support team may copy them into tickets, and a backup process may preserve them for years. Without clear ownership, nobody may know which copy is authoritative, which copy should be deleted, or which group can approve access. Ownership also matters when data is shared with vendors, partners, or cloud providers. The organization may transfer processing duties, but it does not transfer all responsibility. Contracts, service agreements, and security reviews help define those duties, but someone inside the organization still needs to manage the relationship. If a vendor has an incident, the business must know what data was involved, what obligations exist, and who makes decisions. Ownership is the human side of security architecture. Environmental requirements can also drive architecture decisions. Some systems need special physical conditions, such as stable power, cooling, humidity control, dust control, fire suppression, secure rooms, or protection from vibration and weather. A small office server closet may be acceptable for a low-risk local service, but it may be a poor choice for a critical system that must run continuously. Industrial sites, healthcare facilities, ships, remote locations, and field offices may have environmental limits that affect secure design. Cloud services can reduce some physical burdens, but not every workload can move to cloud, and not every location has reliable connectivity. Environmental constraints may also affect backup, recovery, monitoring, and maintenance. If a system sits in a remote facility with limited staff, the architecture must account for how it will be updated, repaired, accessed, and protected. Physical reality is part of security. Scalability is the ability of an architecture to grow or shrink as demand changes. From a business perspective, scalability supports growth, seasonal demand, new customers, new regions, new applications, and changing workloads. A design that works for a small team may fail when the organization expands. A storage system may fill up, an identity process may become too manual, a network design may become crowded, or a logging system may become too expensive at higher volume. Cloud services can make scalability easier, but they do not remove the need for planning. Scaling without governance can multiply misconfigurations, duplicate data, and create unknown assets. Scaling on-premises may require earlier capacity planning, budget approval, and physical installation. Security architecture should scale controls along with systems. Access review, monitoring, encryption, backup, and incident response must grow with the business, not lag behind it. Risk ties all of these trade-offs together. Risk is not only the chance that something bad could happen. It is the combination of likelihood, impact, uncertainty, and business context. The same technical weakness may have different risk depending on what system it affects. An exposed test application with fake data is not the same as an exposed production system with customer records. A short outage in a non-critical tool is not the same as downtime in an identity system that blocks the entire workforce. A data sovereignty issue may be a minor concern for one dataset and a major legal problem for another. Architecture decisions should be based on risk appetite, which means the amount and type of risk the organization is willing to accept in pursuit of its goals. Security should reduce risk, but it cannot reduce every risk to zero. Business continuity and recovery expectations are part of risk-based architecture. A system that supports a critical business process may need stronger backup, faster restoration, geographic redundancy, and tested failover. A less critical system may tolerate a longer outage and simpler recovery. Recovery time objective, RTO, and recovery point objective, RPO, help translate business impact into technical requirements. RTO asks how quickly the service needs to return. RPO asks how much data loss the business can tolerate. These are business decisions before they are technical designs. If leaders say a system must recover in minutes with almost no data loss, the architecture will cost more and require more complexity. If the business can tolerate a longer recovery, a simpler design may be reasonable. Architecture should match the real impact of disruption rather than using the same recovery target everywhere. The hardest part of business architecture is that the best security answer is not always the strongest technical answer. A highly restricted design may protect data but make business operations too slow. A low-cost design may save money but create unacceptable exposure. A globally replicated cloud design may improve performance but create data sovereignty concerns. A private environment may increase control but reduce scalability and increase staffing demands. A simple classification model may be easier to follow but less precise. A detailed classification model may be more accurate but too hard for people to use consistently. These trade-offs should be made openly. When decisions are documented, the organization can explain why a design was chosen, what risk remains, and who accepted that risk. Silent assumptions are dangerous. Clear trade-offs support better security, better budgeting, and better accountability. Business architecture trade-offs remind you that security must serve the organization's mission while protecting it from harm. Data sovereignty tells you that location, law, and access paths matter. Classification tells you that not all information deserves the same handling. Cost tells you that controls must be sustainable, not just impressive. Ownership tells you that someone must be accountable for systems, data, access, and risk decisions. Environmental requirements tell you that physical conditions and operational realities shape design. Scalability tells you that architecture must support change without losing control. Risk tells you how to choose among imperfect options. Security architecture is strongest when it respects business constraints instead of ignoring them. The goal is not to build an environment that sounds perfect in theory. The goal is to build one that protects the right assets, supports the right processes, and can be operated responsibly over time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.